Hello and welcome to Guessing the Methods Exam Part 2. Now last year I guessed the Methods Exam, but this year my past students have guessed it. They're real clever. They started their own tutoring company, link in the description below. They've got like all this cool stuff. Check it out. Let's get started. So this is the first question. We're going tech active here. Pause the video, try it out yourself. And now I'm going to jump into it. All right, we are looking for a point of inflection here. And when I think points of inflection, I think second derivative. And I'm going to do some clever stuff with my calculator this time around. All right, so here's my calculator. I'm in graphing mode. It's a polynomial, so I don't have to worry about degrees or radians or anything like that. So the thing that I really wanted to show you here, that in graphing mode here, I can click Option and Calc, and I can choose second derivative. That means that I don't have to calculate this derivative by hand. Instead, I can just say, tell me what the second derivative of this equation is. So I just type that in. So I've typed it all in. I didn't want you to watch me do that. That's boring. There's this little thing at the end that says like x equals. We just type a little x in there. You can also just not type anything there. It'll guess that you want an x in there. All right, I'm drawing it, and I get a graph that looks like that. Now that is the second derivative of this. So I just did a quick little zoom out there so we can see a little more of it. It's a straight line. That makes sense. The second derivative of a cubic is going to be a linear equation. Now, the point of inflection is found where the second derivative is equal to 0. But I've got more to say about that because there is something important to say about that. All right, so where is the second derivative equal to 0? Here, right? So I can do a little g-solve here. I can do roots. And there we go. X is equal to 1. So that is the only place where this linear equation meets the x-axis. So that is the point where our point of inflection is. Our answer is 1. Okay, so what's the important thing that I wanted to mention about that? It's a little caveat about this point of inflection thing, right? So what I've said so far is that points of inflection can only occur when the second derivative is equal to 0. But the thing that I wanted to mention is just because the second derivative is equal to 0 does not mean that a point of inflection is happening. For a point of inflection to be happening, the second derivative needs to be equal to 0. To the right of that 0, you need to be above the x-axis, and to the left of it, you need to be below, or vice versa. Because a point of inflection is a change in concavity. So you're changing from having a positive gradient to a negative gradient, or a negative gradient to a positive gradient. So if that graph didn't look like that, but instead looked something like that, it would be tempting to say that that was a point of inflection, but it's not, right? Because the second derivative is equal to 0 there, but positive here and positive here. The gradient's positive there and positive there. So I hope I'm sort of getting my point across here. The point of inflection, the second derivative needs to be equal to 0 for a point of inflection to be existing, but just because the second derivative equals 0, that's not enough to know that there's a point of inflection there. Why have I mentioned all of this? Because there's a big controversy in last year's exam that hinged on that exact fact. All right, so we've got that question correct. Let's celebrate and move on to the next question. All right, we're tech active again. You can use your calculator as much as you like. Pause the video, try it out for yourself. All right, so I'm going to do this one here. Determine at what point the gradient of that function, where x is greater than 0, is equal to 1. All right, so again, I'm going to use my calculator to its full capabilities here. So this is the function, and I want to know when is the gradient of that function equal to 1. So I don't want that function, I want the gradient function. So I can do similar to what I did just before. So I can click Option, Calc, and I can do ddx, so I can do the gradient function. So let's type the function in there. Okay, so it's going to look something like that, ddx, the function, and then I have typed x into that little space there. All right, so we're going to draw that, and we get something like this. This is a good time for you to check that you are in radians mode because we're graphing a trigonometric function We can see we've got like a pi in there. So it's assumed that this is in radians mode, not in degrees mode. So what are we trying to find out? We're trying to find out when is the gradient equal to 1. Usually you'd be finding when is the gradient equal to 0, where is a turning point. But we don't want to know that. We want to know when is the gradient equal to 1. Okay, so what I'm going to do here, actually, I'm going to go back to my graphing window, and I'm going to create a new equation, just y equals 1. Okay, what does that do? All right, now I've got two equations. I've got a nice little line running along there for y equals 1. So now I can just click gsolve intersect and find where those intersect. And you can see there's going to be heaps of answers. The question says, determine at what point the gradient of the function where x is greater than 0. Okay, so anything where x is negative is not going to count. So that answer is not okay. That answer is not okay. That answer is not okay. This answer is not okay. Okay, this, we're in business. This is the only option that appears here, 1.2477, 1.248. So I think we found our answer. Our answer is A. Really trying to push our calculator use there, because you didn't have to do all of that, right? You didn't have to find the derivative on your calculator the way I did. You can find the derivative of cos 3x minus pi 12 by hand and then type that in. But I'm trying to like save us a step if we're fluent with our technology. All right, celebrate. And next question. All right, so what have we got? Probability density function. This is tech active. Have a try. All right, so I'm going to first of all, the most important thing I think is just to draw a picture. The reason I think drawing a picture is useful is because it orients yourself. You understand what you're doing. It doesn't have to be an amazing picture because we're just going to draw something here. It's a probability density function between 0 and k. And if it's a probability density function, that area needs to be equal to 1, right? Now, this is not a perfect drawing or anything. Just trying to get an understanding of what's going on. I'm going to try to use my calculator to its maximum efficiency here. All right, so I've already typed in my function, 8 minus x cubed. I'm going to draw that. Okay, and you can see that's what I've got, right? Now, instead of doing a whole bunch of like algebraic manipulation to try and find k, I think what I'm going to do is just a bit of trial and error. Now, it can't be like a negative x value, a negative k value. That doesn't make sense because this indicates that k is larger than 0. So let's get rid of a, but let's just try b, c, and d and see how we go. So I'm going to go over here, gsolve, over here, and I'm going to do a integral. And I'm going to integrate between 0 and my first mystery k value, 0.015. Okay, so the area there, written right there, is 0.1199. That's too small. I want an area of 1. Now, this number's not much bigger, so maybe I'll just jump directly to answer D and see how we go there. So, gsolve, here, intersect. I'm going to go lower bound of 0 and an upper bound of 0.125. All right, I got an area there of 0.9999. That's definitely approximately 1. So I think that's going to be my answer. You know, if it was an exam, because it's not taking me very long, I think I probably would just double check the last option, 0.083. And that's like 0.66. So that doesn't feel right. The answer here is D. Okay, so that is how I would solve this question. There are other ways to do it, because the integral between 0 and k needs to equal 1. So we might be able to do some kind of like n-solve-y type stuff with this. Something like this, solve n equal, 1 equal blah, 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 comma k. I just did alpha k and alpha k there. You can see it spits out multiple answers here. I'll leave you to think about why it could spit out multiple answers, but you can see one of our answers is 0.125. So I've solved it. I've solved it 2 different ways, calculated both times. Yay. Next question. All right, so tech active again. Give it a try, and then I'm going to start solving it. All right, I might just get rid of part B because we don't need to deal with that at the moment. And now let's solve it. A game at the Ekka, 30% chance of winning, where winners are rewarded with a show bag. A group of 8 people decide to play. Determine the probability that 4 or 8 people win a show bag. All right, we're looking for the probability that x equals 4 or x equals 8. So relatively straightforward. With an or, you need to be thinking about plus. So we need to find the probability that x is equal to 4 plus the probability that x is equal to 8. And this seems like another great opportunity to get out our calculator and just let our calculator do the hard work. So here I am, I'm hanging out in stat mode, and I go to distributions, and this is a binomial, right? So binomial and BPD, because I'm looking for exactly 4 or exactly 8. Okay, so data variable, not data list, data variable, and we're looking for x, number of trials, and probability of success. So probability of success, 0.3. Number of trials, a group of 8 people. And number of successes, 4. Okay, that should give me a number. 0.1361. That'll do. Plus, and then let's do it again, but now we need 8 successes. That's going to be, an incredibly small number. That is just so ridiculously small, right? Like that's like, okay. So I now just need to add these two numbers together. It's like that small. So given I was thinking like 4 decimal places is enough here, if I add that to that, those decimal places aren't going to change. So I'm going with 0.1361. Do I imagine a question like this on an external where you have something so small that adding it to the other number is going to make any difference? No, I don't. But can I imagine a question where like maybe that was x equals 7 or x equals 6? Yes, absolutely. Gives us some fun stuff to talk about. Let's look at the second one here. All right, second one, it's a given thing, right? 4 people win a show bag, given at least 2 people win a show bag. So the probability that x equals 4, given x is at least 2 people, greater than or equal to 2. All right, so to do that one, we need the probability that x equals 4 and x is greater than or equal to 2. Now, I am going to change that in a second. I'm just leaving that for now. And then divide it by the probability that x is greater than or equal to 2. Now, the reason I'm going to change that numerator is because the probability that x is equal to 4 and x is greater than or equal to 2 is just the same as the probability that x is equal to 4. It's a Venn diagram completely inside itself. So we actually don't need any of this. We can just say the probability that x is equal to 4 over the probability that x is greater than or equal to 2. All right, luckily we know the probability that x is equal to 4. We've already calculated it. So we just need this x is greater than or equal to 2. And that's a job for our calculator and BCD. All right, so I'll hide over here. We've got binomial, we've got BCD, and we need to fill in here. Now, the question says at least 2 people. So that's 2 or more, right? So the lower is 2, the upper is 8, number of trials is 8, and the P is that. And we've got an answer, 0.7447. And obviously we can just calculate that. So my controversial take is that you should bring 2 calculators into the exam. One of these less sophisticated ones where you can do little calculations like this, and then your fancier one where you can do all your graphing and things like that. Tell me in the comments whether you think that's stupid or like the best idea you've ever heard, or somewhere in the middle. All right, so my answer is 0.18276. I've started a trend of 4 decimal places, so let's stay with that, 0.1828. Now that was part A of this question, but there was one more part to this. So let's dive into that one. I think we should celebrate first. Next question. All right, so we're going to do the last one here. Determine the minimum number of people that must play for the probability that at least one person wins a show bag to be greater than 95%. All right, so how am I going to go about this? Let's write it out. The probability that x is greater than or equal to 1, that's the at least 1 bit, it needs to be greater than 95%, 0.95. All right, that's what we're going for. Now, this, right, leads to the fact that the probability that x is equal to 0 must be less than 0.05. Okay, so think about that for just a second. All right, probability that x is greater than 1 is greater than 0.95. If that's true, then the probability that no one gets a show bag must be less than 0.05 for that to be true. We're looking at complements of each other. All right, we know how to find the probability that x is equal to 0. I've just flipped this around, flipped the sign and flipped our things, just because I want to write this as a formula. All right, 0.05 is greater than. Now, we don't know the number of people. That's the thing that we need. So, the number of successes is going to be 0, but the number of trials is the thing that we don't know. All right, how many successes do we want? All right, so the probability of success is 0.3, and we want 0 successes. And the probability of failure, 1 minus probability of success, is 0.7. And how many of those do we want? Well, we don't know, but we want all of them. We want n failures. So there's a bit more that we can do here, right? Because, again, we don't know what n is, but when it comes to combinations, there's only one way that you can have 0 successes. So that's just 1. And this 0.3 to the power of 0 is just 1. And then this 0.7 to the n. So in other words, what we're looking for is a quite simple equation. We just want 0.05 to be greater than 0.7 to the n. Now you can proceed here with logs, but Tech Active, let's get our calculator out. So I've done a little solve n here, and you'll notice that I've used the equals sign, right? I haven't been able to find a nice way to use greater than here. But that means that if this equation was 0.05 is equal to 0.7n, then using our graphics calculator, GCD, we would say that n is equal to 8.399. All right, so then the question becomes, how do we interpret 8.399? Well, first of all, our answer cannot be 8.399, right? Because we're looking for a minimum number of people. So I've narrowed it down. My answer must be 8 or 9. Now, which one of those is that? Now, let's think about this. My calculator told me that if I wanted 0.05 to be equal to 0.7 to the n, then n would need to be 8.399. But I don't want that. I want 0.7 to the n to be less than 0.05. And for it to be less than that, I would need that n to be a larger number. So we need to round this up to 9. Now, my answer is 9 here. You might be having trouble with the inequalities. It's not something we do a lot of. You can double check this answer, of course, by just going into your calculator and doing it all over again using BCD here. So let's see if I'm right. I want a lower value of at least 1, right? So 1. Now my upper value, I've said my upper value is 9. And I've said my number of values is 9, right? Because I want, the question was how many trials, and I've said 9. So I went between 1 and 9 successes from 9 trials and a 0.3. Now, if I'm correct, this should spit out a number greater than 0.95. And it does. Okay, 0.959. So that makes me feel more comfortable. What if I'd round it down? What if I'd only gone 8 trials? Oh, that only gives me an answer of 0.94. So rounding down wouldn't have been the right play. 9 is my correct answer. Really good idea. If you've got to go one way, if you can check with your calculator going the other way, tip top. Okay, I think the answer is 9, and I think we can celebrate, and move on to the next question. All right, it's a big one. Have a read, have a look at it, and then we're going to get started. All right, so in the exam, they're going to give you some blue paper that you can just scribble on as much as you like. It'll never get marked, so don't write all your answers on it, but you can scribble on it. These are the sorts of questions where you should absolutely be drawing a picture, right? And so I'm going to draw a few pictures here because it says blah, 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 blah. There's like a wall, and then there's like some sort of foldable fence, right? And it's going to make a triangle. Okay, what more information do I have? Oh, the foldable fence is made up of two lengths, 10 and 7. Right, that's an angle there. It also says that it's making an angle of 37 degrees between the 10-meter fence and the building wall. Right, so that's a 37-degree angle. Okay, so I'm going to tidy this up a little bit. Okay, that's a neater representation. That just means I've drawn the picture twice on my blue paper. And then there's this last bit of information here. Given that the longest side of the triangle is the 10-meter fence, well, my picture doesn't look like that. I've got a long wall and a shorter 10-meter fence. Okay, I see what's going on here. We've got one of those like weird ambiguous case sign rule style questions. My 7 shouldn't be here. My 7 should be like that. I think that's how it's going to go down. Okay, so I'm just going to get rid of that, and I'm going to go from there. So to find an area of a triangle, I definitely need like 2 lengths and an included angle. And I don't have an included angle at the moment. I don't have this length here. If I had this length, I'd have the included angle. I could do the area. Okay, I just need to start finding stuff. So why don't I find this angle using the sine rule? We've got sine theta over 10 equals sine 37 over 7. Opposite sides and angles. Rearranging, we want to get this theta by itself. So sine theta equals 10 sine 37 over 7. And theta is equal to inverse sine of 10 sine 37 over 7. Okay, now this is a very good opportunity for me to reiterate that if I can find it, having a calculator like this is super useful because I can just punch this in. Also, I need to be in degrees mode, and half the time my other calculator is going to be in radians mode. So my answer is 59.287 degrees. But we also have another answer, right? Because clearly my drawing does not have an angle of 59.287. The other angle that this could be is 180 minus 59.287, which is 120.413. It is at this stage that we can reject 59.287. Why? Because we've been told that 10 is the longest side. And the longest side needs to be opposite the largest angle. If this was 59.287, then the largest angle would be here, because the internal angles are 180. If this was 59 and this was 37, this would be bigger than 59, which would make this length larger than 10, and so we can reject this. Why? Because 10 is the longest side and theta is opposite. So it must be the largest angle, 120.413. All that work was to get that angle. I've got that now. Let's get rid of that. Now what I really came here for was the length of x, so I can redo my sine rule type stuff again. So if I know 120.413 is this, and if I know that that's 37, I can easily find this by doing 180 minus 37 minus 120.413. And that will be 22.587. All right, so now that I know that that is that angle, I can start putting some stuff into a sine rule again. Sine 22.587 over opposite angle, which is x, equals, let's use the angle we started with. So sine 37 over 7. All right, rearrange that by bringing x to the top over sine 37 and solving that for x. X equals 4.467. Not sponsored. So now I know that length is 4.467, but I still need to find the area of the triangle. If only I had a formula for that. All right, there we have it. Area equals, let's use a different color so we don't get too confused. Area equals half BC, so 4.467 times 10 times sine 37. All right, let's find an answer to that. 13.44 meters squared. Don't forget your units, like people love units. I had to double check this. For some reason I wrote 413 instead of 713 here, which changed that number, and changed that number, and that number, and finally leads me to this answer here. Now I'm allowed to celebrate. Neato. Now the thing that I really want you to take away from this is that when you're reading big long questions, you've got that scribble paper, use it, draw a picture, draw a picture, draw a picture, draw several pictures while you're going until you're happy with what's going on and then understand it. You really don't have to think too much about the ambiguous case if you're drawing pictures and thinking about it. The ambiguous case will come to you naturally when you think about what you are doing. All right. That is 5 more questions, all tech actives. We had some fun with the calculator. I've left you some jobs to do. Tell me what you think of this calculator, if you love it, if you hate it. Tell me how to do that binomial inverse question, if you've got a good way of doing it. Some people might have a slightly more efficient way of doing this using other rules, but I've sort of stepped through it pretty methodically. All right, that's been part 2. Thanks to my peeps over here for writing the exam. Those questions were mint. Go and check them out at the link in the description below. Catch you in part 3.